Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video, we're going to implement an algorithmic stock trading strategy in Python. So let us get right into it. Well, I think it goes without saying, but as always, I need to include this disclaimer here. This video is not investment advice. It is not financial advice. Don't listen to me when it comes to finances and investing. I am no stock professional. I'm no investing professional. I'm not a financial professional. The only thing I'm doing in this video is presenting an algorithmic trading strategy in Python. So I'm showing you how you can do something in Python. If you choose to use it for your investments or not, that's your decision, your responsibility. I'm just showing you the programming part. I'm going to use a financial strategy. I don't say it's good. I don't say it's bad. I'm just showing you how to do it. So don't take this as investment advice. So having said that, what are we going to do? We're going to just load some stock data and we're going to apply a very simple rule, which is when the averages, the moving averages cross, we're going to sell or buy, depending on which one crossed the other one. We're going to talk about that in a second. First of all, what we need is we need to open up a CMD command prompt and we need to install two libraries. One is pandas data reader, like that, in order to get the stock data. And the other one is matplotlib for the visualization part. So we're going to start by importing datetime as DT. By the way, let me just reposition my camera. I always forget this before I start the video, so I need to do it right while I'm recording. There you go. So import datetime as DT. Then we're going to say import matplotlib.pyplot as PLT. And last but not least, import pandas data reader as web. So first of all, we need to decide which moving averages we're going to look at. So a moving average is basically just the average price over the last 30 days, 50 days, 10 days, 100 days, 200 days, whatever. And I'm going to create two variables here, which I'm going to call MA1, and it's going to be 30, for example, and MA2, which is going to be 100, for example. So we're looking at the 30-day moving average or the 100-day moving average, and we're looking into the graphs and we're trying to figure out, okay, when are they crossing? And once they cross, we're either going to buy or sell. This is the basic strategy. I don't say it's a good strategy. I just say it's a strategy that we can use here. And you can then see the results. You can test it on past data and see if it would have worked or not. So what we're then going to do is we're going to define a time frame. We're going to say, okay, start equals dt.datetime.now minus dt.time delta. This basically means we take the exact moment right now when we run the script minus a certain time delta minus, for example, in this case, we're just going to say days equals 365 times 3. So the last 3 years. And the end is going to be dt.datetime.now. So we're looking at that time horizon here. And what we're now going to do is we're going to get the data for a specific stock in that time frame. So we're going to say data equals web.dataReader. For example, we're going to look at Facebook from the Yahoo Finance API from start to end. So we have the data now, and what we want to do now is we want to get the moving averages for that data. So we're just going to add two new columns. We can first of all run this to see what it looks like without the two columns that we introduced. So I'm going to run this and you can see what this looks like. It's going to take a while. There you go. We have high, low, and in between we have open, close, volume, and adjusted close. So it's not displaying all columns here, but we don't have anything like moving averages. So we're going to add those by saying data, and now we're going to just say fstring SMA underscore and now MA1. So basically a moving average of that size is going to be data adjusted close. Adjusted basically just means close value adjusted for stock splits, because sometimes companies do stock splits and then the price changes, but the market cap does not change. And we're going to just get the rolling window is going to be MA1, so that's just a time frame, and we're going to get the mean. We're going to do the same thing for the second moving average. And we're also going to adjust this here. There you go. And then what we're going to do is we're going to say the data is basically the data from, or the data.ilog. And we're going to start displaying the data from MA2. Why are we going to do that? Because up until this point, we don't have any moving averages really, or we have biased moving averages because we cannot look at the past, in this case 100 days, because we have no 100 days to look back to. So we're just going to cut off the data in the beginning. This is just my way of doing it. And what we're now going to do is we're just going to say plt.plot, and we're going to visualize the whole thing. So we're going to say plt.plot. We're going to plot the adjusted close value here, and we're going to say the label is share price, because we're going to add a legend later on, and the color is going to be light gray. So this is just the stock price. By the way, let me just also add a style here. So what we're going to do is we're going to say plt.style.use, and we're going to use dark background just because we can. And down here we're going to we're going to plot the data SMA, and again we need to use an F string because we don't have static values, MA1. We're going to plot that. The label is also going to be an F string, SMA MA1. And the color in this case is going to be, let's say, orange. And we're going to do the same thing here with 2, and the color here is going to be purple. And last but not least, let's add a legend. So plt legend location equals upper left, and plt dot show. So this is not the strategy yet. We're just looking at the data set. We're just looking at the moving averages so that we see what we're actually working with. We have a problem. Yeah, purple is not a color. I mean, purple is, but what I wrote is not a color. So let's see what happens now. There you go. So this is what we're working with. This here is the stock price. This almost white line here is the stock price. And those are the moving averages. So the purple line here is the 100-day moving average, basically just the average of the last 100 days. And you can see that it moves slower and smoother, whereas this is more sensitive to local changes because it's only 30 days. And basically, just for understanding, a one day moving average would be the stock price itself. So because we're just looking at 1 day. So the larger the number is, the smoother and the more linear a curve is going to be, you could say. And what we're going to do now as a trading strategy is we're just going to buy and sell on those crossings here. So whenever these two lines, these moving averages here cross, we're going to either buy or sell. This is what we're going to implement. And again, I'm not claiming that this is a super intelligent strategy. I mean, after all, it's just technical analysis, so we're not doing any fundamental value investing here. But this is one thing that we can try, and we can see if it works or not. So what we're going to do here next is we're going to implement the algorithmic trading. So we're going to say, okay, we have a set of buy signals. Buy signals is an empty list, and we're also going to have the sell signals. Those are just going to be the signals that indicate, okay, sell at this point, buy at this point. And we're going to have a trigger, and this trigger is going to change because when we buy, we're going to change this trigger. When we sell, we're going to change this trigger so that we know, okay, what is the current state and when do we actually pass into another state, or are we all the time in the same state? So we need to notice changes, and without a trigger, we cannot really notice changes. And what we're now going to do is we're just going to say, okay, for x in range, the length of the data, so basically for everything in the data, we're going to say if the moving average, in this case, MA1, if that dot ilog x, so that position at this particular row, if the moving average 1 here is larger than the same thing, so SMA, but this time MA2, so the second moving average I log X, if that is the case, and the trigger is not equal to 1, I think I have a mistake here. There you go. And it's not equal to 1, then we're going to have a buy signal. So then we're going to say buy signal, append, and we're going to append the adjusted close value at the location X, which is the current iteration. And we're going to append sell signals as well, because we want to have none, or not necessarily none. In this case, we're going to use nan, which is not a number. We want to have a not a number value if there is no signal, basically, so that we have a full list and we don't just have some gaps that can be misinterpreted. So we're going to say sell signals in this case. We're going to append float nan, which is going to append a not a number value. And we're going to set the trigger to 1, because remember, up here we're saying, okay, if it's not equal to 1, which means that now it is equal to 1. So even if that is the case, we're not going to get into that again. So this is what I mean by trigger. We're checking for that condition, but only once. If we have seen this condition and we have acted on it, we don't want to do it again right away. We want to wait for the trigger to change before we get into that case again. Because otherwise we would constantly have some signals for buying or selling, which is not what we're trying to do here. So now we're going to do the other case, which is, let's say the SMA MA1 I log X is less than the data SMA MA2 I log X, and the trigger is not equal to -1, so we're going to use a different trigger here. By the way, you can also use enums or whatever you want. I just think it's convenient to use a number here. So this is basically just the opposite case. If the moving averages are the opposite way, so MA1 is less than MA2, if that is the case, and it's the case for the first time, so a change happened here, when we passed that point, we're just going to say buy signals append float, come on, nan, and we're going to say sell signals append the actual price. So in this case, data adjusted close at the location that we're currently at. And the trigger is going to be set to -1. And last but not least, if nothing happens, we're just going to append nan values so that we fill up the list. So if we don't have any change in the trigger, we're just going to continue to put in nan values. So append with 2 p's, not with 3 p's, float nan, and come on, sell signals. There you go. So we're almost done. The only thing we now need to do is we need to create 2 more columns, and then we're going to visualize everything. So we're going to say data buy signals is going to be buy signals, and data sell signals is going to be sell signals. There you go. And print data. By the way, because sometimes people are asking in the comments how I'm also always editing stuff like that. So for example, how I change a word here with my keyboard. This is Vim, so those are Vim bindings. If you're interested, you can just look into Vim. I have a tutorial on Vim, and there's a plugin in PyCharm that allows you to do that. Just a side information here because some people are asking all the time. So we can print the data, yes, but before we just go ahead and print the data, we're also going to plot everything. So we're going to say plt plot, and we're going to start with the basic adjusted close values. So just adjusted close, and the label is going to be share price. By the way, I think we can just copy at least these 3 lines here with slight changes, because we don't want to have a color here necessarily. We're going to say alpha equals 0.5. This is basically just transparency here. And we're now going to also change the color here to pink. And we're going to change the line style so that we're not too confused. We need to have a way to distinguish all these individual lines. So line style of the moving averages is going to be just a dashed line. The price is going to be a normal line. And now we're also going to scatter the buying signal. So we're going to say PLT scatter, and we're going to scatter on data index, which is the X value. We're going to scatter the buy signals. So nans are not going to be scattered, and all the other values are going to be at the prices where we have to sell. So this is what we're going to do. Label buy signal. And the important thing is the marker. We're going to buy with a hat symbol like that. And the color of that is going to be green. So basically a hex value, RGB, red is 0, green is FF, and B for blue is 0, 0 again. And the line width is going to be 3. We're going to copy that line, and we're going to do the same thing for the sell signals. Oh, come on. For the sell signal here, but we're going to use a different marker. We're going to use the downward arrow, which is just a V. And the color is going to be red, so FF0000. There you go. And last but not least, plt.legend, location, upper left, and finally plt show. There you go. That's all we need to do. Let's see if we don't have any mistakes. If we don't have mistakes, we should see the result. This is the first plot. And this is the second plot. It seems to work. First of all, let's see down here. You can see we have sell signal right away. Then we have nan, 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 and in between some buy and sell signals. And the result is this. This is the result. We have a sell signal in the beginning, a buy signal here, selling it here, buying it here, selling it here, buying it here, selling it here, buying it here, and so on. And of course, this goes up until today. So right now we don't have a signal. The last signal was buy. So up until now, we shouldn't have sold according to this algorithm. But you can see that it does not always perform very well. You can see, for example, here it says to sell, here it says to buy. Okay, in this case here, we would even have a small gain. So we buy here, sell here. Then we buy here, but we sell here. So this is a loss. We buy here, we sell here, which is a gain. And then we buy here, and we don't know what happens in the future. But this is what our algorithm says. Now, we can also change the moving averages if we're interested in that. So we can go ahead and say, okay, let's look at 50 days and 100 days, and we can see what the result for that is. Let me just comment that out because we're not interested in that. And we don't want to waste time with the first plot. But you can adjust that. So in this case, you would see a bit different signals, or are they actually the same signals? No, they're actually the same signals. Did I actually use the windows, the right windows? Where was it? Oh yeah. So maybe it just doesn't change for this particular company, but let's go with another company. Let's say Tesla, for example. Let's go back to 30 because I think that's a reasonable thing to look at. And for Tesla, you're going to get different results. Now, again, this is just a technical analysis trading strategy, so there's no reason to believe that it's going to give you extraordinary results. Here you can see Tesla basically buy, sell, on a very similar level. It says sell here, buy here, and sell here. So actually, if you would have listened to this algorithm here when it comes to Tesla, and of course you shouldn't listen to that algorithm, it's just a programming tutorial, but if you would have listened to this algorithm, you would have made a lot of money in this particular case. I'm sure I can find some counterexamples if I just look long enough. But we can look at a bunch of different companies and see how this model would have performed. And this graph that we see here all the time, it's not just a past prediction, it's also a current prediction, as you can see here right away. So even though it's not necessarily today, the last signal for Apple was a buy. So if you were following that model, you would have to buy Apple now and sell it the next time it says to sell. So we would have a sell here, a buy here, a sell here, which is a tiny gain, a buy here and a sell here, which is a good gain, a buy here, a sell here, which is a small loss, and now we have a buy here, and who knows where it's going, right? So this is something that you can look into. You can also manipulate this thing here to do what you want, but that's up to you. This is how you build an algorithmic trading strategy in Python. So that's it for today's video. Hope you enjoyed and hope you learned something. I just saw that my camera was blocking the last buy signal for the Apple stock. So before I maximized, you saw the buy signal, then it was covered by my camera. I hope this was not too annoying. However, if you liked that video, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.